In this demo we will explain the main features of the CODECO Experimentation Framework or else CODEF, and how the community can deploy and use it to perform automated experimentation for Kubernetes and CODECO-based edge cloud deployments. The only prerequisites for CODEF are running it on an Ubuntu 22.04 machine with Docker, JQ, and passwordless SSH access to the nodes for deployment. After cloning the repository, users need to perform a basic setup before executing experiments or deploying a cluster. First, the user needs to create a configuration file, similar to this example. This file serves as a template for setting up the cluster, including details such as admin credentials, cloud server information, Kubernetes distribution options, and VM specifications like the OS image used to deploy the cluster from scratch, as well as the names, IP and MAC addresses of the master and worker nodes. Once the configuration file is prepared, the user can execute a single script, as shown here. In this script, the user specifies the previously completed configuration file to use, Kubernetes-related parameters such as the chosen Kubernetes distribution and network flavor, as well as the applications or software to be installed within the cluster. CODEF automates software deployment through its resource managers, utilizing custom Ansible playbooks. It supports a diverse range of applications, including deployment tools like Argo and Helm, networking solutions such as various CNI plugins and the standalone L2SM CODECO component, monitoring and observability tools like Prometheus and Grafana, multi-cluster management platforms such as OCM, Lico, Karmata, and Submariner, load and stress testing tools like KubeBurner and more. Of course, both the infrastructure managers and resource managers can be extended to support the user's specific needs. Additionally, users can enable or disable key CODEF features, such as using Jaeger for enhanced visualization or enabling the DHCP service for deployments where the cloud server and CODEF operate on machines in different networks. Finally, the user can run the script. CODEF first verifies that all prerequisites are met. If anything is missing or the user's input is incorrect, it provides feedback, prompting the user to make the necessary changes before proceeding. If everything is fine, CODEF then checks whether the necessary images are available locally. If they are not, CODEF builds them and proceeds to generate and execute the Docker Compose YAML file. Users can monitor the entire process in real time on their screen, with Ansible visualizing each task as it executes. During this process, the user can observe the nodes created and represented as containers in Docker Desktop, managed by the resource managers of CODEF and the selected infrastructure manager. Once the script completes, the user can access a fully deployed and functional cluster. They can execute experiments and familiarize with the CODECO OSS and its components across multiple environments with minimal effort. The cluster can be easily discarded and redeployed, minimizing deployment time and need for maintenance. CODEF can be used within CODECO to deploy standalone components, such as the L2SM, or the entire CODECO OSS. To automate the experimentation process, CODEF leverages the experiment controller and related scripts to deploy a clean cluster for each run. Based on the parameters defined in the scripts, CODEF executes the experiments, generates the corresponding results and stores them in a directory named after the experiment. Users can utilize the results processor to visualize their results through generated plots or to create reports. These reports are produced as LaTeX-based PDF documents, integrating visualizations and plots to present experimental outcomes in a well-structured format. CODEF is already being used for the performance assessment of network plugins, including the L2SM component, the evaluation of AD methods implemented as Argo workflows, and the integration with external edge environments and testbeds like EdgeNet. One of CODEF's features currently under deployment is its ability to support node contributions. This capability enables partners to dynamically share resources, fostering collaboration and strengthening the platform's appeal for use cases requiring distributed resource sharing and experimentation. In these lines, a cluster will be created using the Node Contribution Infrastructure Manager, with a server listening to a specific port. Afterwards, another partner will run a simple script which will take a clean LVM snapshot of the node, connect to the server and add their node in this existing cluster. After 2 reboots, the node reverts to its clean state. Thank you for watching this brief demo showcasing some of the key functionalities of the CODECO Experimentation Framework.